Welcome to the lecture on efficiency programming. We will study the basic C data types, how to use these basic C data types to get the compact code, compiled and compact code, that is to get the efficiency programming. So there are necessary, the programmer should know to write the efficient programming is the programmer should know the C code with a different style such that the program should, the compiled code should have the less machine cycle with compact size. And the another important, the point the programmer should know is the process of compilation and the optimization. Already we know that the compiling or compiler, the process of compilation is the compiler will take the high code language, high level language to the machine equivalent language. So in the process of compilation, the compiler will not only translate from high level language to the machine, but also it translate to the assembly equivalent. So C compiler have to translate the C function to the assembler. That helps here the C program and then assembly code equivalent and then machine code. With the help of this, the programmer could able to know the way how the compiler can map the different set of assembly or instruction for different C statements and C constructs and variables. And also with the help of assembly equivalent code, visualization of assembly equivalent code, the programmer could be able to identify the problems to achieve the compact or optimized code or to achieve the efficient programming. So with the understanding these, the identified problem, the programmer can rewrite the C code and to get the compact or optimized code. There are few issues with respect to write the efficient programming. The one is the efficient program takes more time as compared to normal programming. To address to this issue, the programmer should not apply the efficient programming approach for entire application. Instead of that, the programmer has to apply the efficient programming approach for selective portion of the application. That is, selective portion means some selective functions and subroutines. Those are executed frequently and those are very important for to achieve the performance. The another issue is the code readability. Obviously, the programmer written efficient code to meet not only the functionality, to meet the high performance, to meet the achieve the high code density, then obviously the logic or algorithm will be not clearly understand. So to address that code readability, the programmer has to write the clear commands along with the coding. To write efficient code, the programmer must be aware of area where C compiler has to be conservative. Uh, the specifically the how the compiler has to map the various elements of the microprocessor, for example, how the compiler is allocating the registers and memory of a microcontroller to the different variables which is that are used in C program, that then the programmer should know the limits of a specific C compiler. Here in this demonstration, we'll focus on the way the compiler has to be conservative, and we should know that the detailed understanding of the architecture of the microcontroller. So by understanding these 2 points, the how we can achieve the optimization or writing efficient code. Let us consider this example to demonstrate the compiler has to be conservative for the unknown value of the variable or data pointer. Here this example is for clearing the n byte of a memory. The clearing logic is defined as a separate function. Here, to clear n number of elements, for that the for loop is used, and the for loop is set such that the n is a maximum value and the n value has to be decremented till the n is equal to 0. But if you look at this function, the n is not specified any value, and similarly the data is, the compiler may not know the type of the data. The data pointer is the pointer for the data type of character or int, not specified here. So let us look at that how the compiler has to be conservative by considering these. See here, so no matter how advanced the compiler, it doesn't know whether n can be 0 or on input or not, right? Therefore the compiler needs to test for this case explicitly before the first iteration of the loop, right? So irrespective of any n value, the compiler has to translate such that it should not be changed after the compilation. Similarly, the compiler does not know whether the data, the pointer for the data is that 4-bit aligned or not. If it is a 4-bit aligned, then compiler can clear 4 bytes at a time by using an int store rather than the character store. If you we'll see that the size allocation of the data type by declaring the different data type, that we'll discuss in the next slide. Nor does it know whether n is a multiple of 4 or not. If n is a multiple of 4, then the compiler can repeat the loop body 4 times or store 4 bytes at a time using int store, right? So from seeing this, by seeing this example, and we can understand that the compiler must be conservative and assume all possible values of n and all possible of alignments of data, right? So this is about the first point, the conservative of the compiler the programmer should know for writing the efficient programming. Let us look at the data type mapping for different data types declared in the C programming. For character, the data type mapping is 8-bit byte. If you declare as a short, then the size allocated for that short will be 16-bit. For int, 32-bit. For long, 32-bit, and long 64-bit. In the previous example, we have discussed about how the data type to be declared for memory. So for example, if I declare data as a pointer for the character type, it says that the data is a pointer for the memory of size 1 byte. Instead of character, if you declared as the short, means data is a pointer for the location of the size of 16. If it is a int 32-bit, means 4 bytes. So the programmer can decide what data type, C data type, has to be declared for particularly memory or for global variables, such that you can save the memory size. So the best preference is the character data type is a better declaration for specifically for the memory allocation. So now we have to look at what type of data type declaration for the variables, like local variables, that we are discussing now. See, let us look at this example. In this example, I is declared as character and sum is also declared as a character. So is that a worth to declare the local variables as a character data type? What happened? See, first we should know that the compiler will allocate the registers for local variables, right? So if you declared I and character as the I and sum as a character data type, then each variable is allocating some registers of R microcontroller. But we know that the each register in the R microcontroller is having the size of 32-bit. But if you declared I as a 8-bit, then I is mapped to the register which is the size of 32-bit, right? So if you look at this loop, so this is an example for adding the array of elements from the memory location. See here, if you are using I as a local variable and compiler will, while assembling or conversion, the I is the register, some one register of ARM is mapped to the I. But in this case, if you declare I, means the I value will be the range of 0 to the maximum will be 8-bit value. 8-bit means 0 to 255. After 255, again it has to change to the 0 only. But I is mapped to the register of one register of R microcontroller, which is the size is 32-bit, but it can able to extend more than 255, extend the size of 8-bit because it is 32-bit. So the compiler will look at this, the type, and compiler has to add few more instruction to achieve this, because if you are not specifying certain instruction, so it may be incrementing after 255, means all 8 bits is 1, then the 9th bit of a register will get updated. So just how what happened if you declared I as a character and I as a short or int, then we look at here the discussion. See here at the first side, if you look at, if you are declaring I character, is it looks efficient? But you may thinking that the character uses less register space or less space on the ARM stack than an int, but it appears to be. But on the ARM, both these assumptions are wrong. So all registers are 32-bit and all stack entries are at least 32-bit. Furthermore, to implement I++, exactly, the compiler must account for the case when I is reached that the maximum value of all bits of I, because I, if you declared I as a character, means 8-bit, all 8-bit of I is reached 11111, that is 255, then but at the same time the I is mapped to the register of our microcontroller, means it should be the answer to, right? So see here, the compiler, how it convert the your C program. If you specify that I as character type, see here I is a R1. See here the compiler is R1 maps to the variable I, sum is maps to the variable R0, right? So if you look at this program, see where is the I plus plus, see I plus plus here for loop, and apart from this, this is the AND instruction, the additional instruction to set that value. After 255, it has to come to the 0 value. If you are not, the compiler, if you are not specifying this instruction, adding this instruction AND R1, R1 0FF is, this instruction will mask the remaining higher 24 bits of that register is masked to the 0, right? So because of the specifying the type, then the compiler is adding some additional instruction to achieve the required logic. See in this case, the compiler insert the extra AND instruction to the range 0 to 255 before comparison with a 64, right? So let us look at this. If in the C programming the I is, if you declared as a integer type instead of character, so the assembly equivalent of which is translated by the compiler, the program will be add R1 comma R1, and there is no addition of AND instruction, right? So by looking at these two, uh, the modification from this to this, we can reduce the one instruction. By declaring data type, we can the increase the number of codes, or we can reduce the number of code. So that from this discussion we can understand that we can optimize the program by declaration of a data type. See, if you are declaring the data type for memory, the preferable is to declare the character type, because you can save the memory footprint. But in case of variables, particularly local variables, you better to prefer to declare that variable as integer. Even you can declare other data types if it is very necessary for like kind of arithmetic operations. So this is about the basic discussion how the data type declaration can impact on the size of the or efficiency of the programming. So just summarize the discussion is that for local variables held in the register, don't use the character or short type unless 8-bit or 16-bit modular arithmetic is necessary, right? For array entries, the global variables held in the main memory use a type with smallest size possible to hold the required data. Then if you are declaring for the short and character type function arguments written, for particularly for array entries or global variables, you should held in the main memory use a type a smallest size possible to hold, that saves the memory. See here, right? So avoid the character short type for argument return values, use the explicit casts, then avoid implicit or explicit narrowing casts in expression because they are usually cost extra cycles. So this is